Hello, ladies and gentlemen. Welcome back to Chapter 9. And yesterday we talked about moles, not the kind on your face, not the furry little kind that dig holes in your garden, but the kind that are found in chemistry. Today we are going to talk about the mole part 2, and we now have a little mascot for this section. Okay, first off, the most important thing you need to remember is what a mole is, and that is simply a type of number, which means that you have a mole of something, just like you have a dozen of something. You have 6.022 times 10 to the 23rd of something. It does not matter whether you're talking about atoms, molecules, or chairs. If you have 6.022 times 10 to the 23rd, you have a mole of them, just like a dozen. Okay. Now, last time we talked about going from how many atoms in moles. We talked about how to go from how many grams in moles. Now, what you'll notice is both of those things are tied to moles. So what you're going to do is, if you want to connect atoms in grams, you need to go through moles. So let's say you want to know how many atoms in a certain number of grams. You go from atoms to moles, and then moles to grams. Okay? Always go from whatever you have to moles, and then from moles to whatever you need to go to, no matter how many steps. If you need to go from grams to atoms, you do the same thing. You go from grams to moles, and then moles to atoms. Always remember, the mole has to be in the middle. That is what connects all these things. So always, always, always just remember, you go from whatever you have to moles to whatever you need it to be. Okay? Now, some examples of how to do that. Okay, this is an example of going from grams to atoms. And the question asks how many atoms in 0.4 grams of carbon. Now, before you even get started, you should realize this is going to be a big number because atoms are very small. So if your answer is not a big number, you've done something wrong. Now, you start out with what you have. You start out with your 0.4 grams. Okay, 0.4 grams. You are given that, and you simply put it over 1. Now, secondly, you're going to talk about 1 mole of, in this case, it's going to be carbon, and you need to do its molar mass. Now, the mass you need on the bottom, because grams is on the top. Mass is grams. So you'll need them in opposite places in order to cancel out when you do your math. Okay, so molar mass goes on the bottom. Now, if you don't remember molar mass, we talked about it last time. It's the mass of a mole of something. You simply look at the periodic chart, look at how many AMUs it has, and what we've discovered is that's how many grams you have. Okay, so when we talk about 1 mole of carbon, its molar mass will be 12.011, because that is what carbon's atomic mass is. Okay, and it just converts into grams when we change it into moles. Okay, now you have moles on top, you need moles on bottom in order so they cancel out. And then you need Avogadro's number. Memorize it. It'll save you time. Okay, so 6.022 times 10 to the 23rd, in this case atoms, because we're trying to find out how many atoms in a mole. Now, if you're wondering where these numbers came from, it is the proportions that we noticed yesterday. 1 mole of carbon has this many grams. 1 mole of carbon has this many atoms. Okay, we talked about those relationships last time. Now, unless you really, really, really love math, plug the numbers in a scientific calculator. Okay, you are going to need to practice putting numbers like this in, especially 10 to the 23rd. If you are not sure how to do that on your calculator, you can always check the user manual, you can Google it, and figure it out that way. Now, essentially what we're doing when you look at all of this is you're taking 0.4 divided by 12.011 times 6.022 times 10 to the 23rd. And remember, this number right here is huge. So since we're going to be multiplying by it, it makes sense that what we're going to have left is a big number. Okay, moles are gone because the upper and lower. Grams are gone because upper and lower. So all we are left with is atoms. And if you plug the numbers in, you are going to get this crazy number that I am not even going to read to you, because I do not want to see any answers that look like this. Okay? If you see answers like this, you need to remember something, and that is significant digits. Okay? I will at least request that they be reasonable. You don't have to go through and remember all of the rules, but if you take this mess and you put it into proper notation with significant digits, scientific notation, you will simply have 2 times 10 to the 22nd atoms. This is the type of answer that I should be seeing. Okay, I do not want to see this. Any teacher that sees this as an answer is just going to tell you to do this. So please do not even bother going there. Okay, so this is how you go from grams to atoms. Now, to do the reverse, one of the ways you can check and make sure you're doing it right is we should get this same answer right here. Okay, going from 0.4 grams to 2 times 10 to the 22 atoms. So we're just going to turn the problem around. How many grams and 2 times 10 to the 22 atoms? Now, if we're doing this right, we should get 0.4 grams. Okay, now going from atoms to moles. When you have atoms on top, you need to put atoms on bottom so they cancel out. You'll notice these are basically the same conversion factors. There's nothing new here, it's just rearranging how they're put in. Okay, so atoms on top, atoms on bottom. 1 mole of, so you have moles on top, moles on bottom, and you are left with mass. And that tells you should have your answer in grams. Okay, all of these other units, atoms and moles, end up canceling out. Now, number of atoms, it tells us. So we put it down, we put it over 1. Avogadro's number, 6.022 times 10 to the 23rd, in this case atoms, are in 1 mole of carbon. That is the relationship, that number of atoms in a mole of anything. Okay, molar mass, remember your 12.011 per mole of carbon. And again, Use that scientific calculator, put the numbers in right, and you will see this horrible number, which is actually a very small number because you'll notice it starts with a 0. So this is less than 1. Again, do not turn in numbers like this. Otherwise, I will make you redo it because this is insane to try to read. Okay, so use your scientific notation and you round it to the nearest digit, which in this case would be 0.4 grams. You do not need all of this. You need right here, you look 1 to the right, and you round up. Okay? You'll have some practice problems in your homework, and we will continue talking about moles next time.